Coordinated motion is really about the robot's motion with other external axes, and we do welding and cutting, but a lot of our customers also buy Universal Robots platform for doing material handling, dispensing, all other types of different applications that we may not support ourselves. So what we thought about is, hey, let's create a feature where they can take some type of external process piece of equipment and control it, but utilizing the external axis functionality that we've created for our welding and cutting applications. So what we did is we created a node called Process Node. So what this does is it allows a customer to take the Universal Robots platform with our software on it, external axes, meaning tracks, rotational positioners, multi-axis positioners, and they can do other things with it. They can do things like weld with another brand of power source that we don't provide, or they can do a dispensing application, or they can do, let's say they could use a nailer and they can control a nailer from this. Anything that would require them to use the robot with an external axis, but then they want that coordinated motion and ease of use that we've created with our user interface. So let me show you what that looks like. So we have a process node down here. It's kind of a diminutive, not well-known node that we've created, and all of our systems have it if you have coordinated motion. So what you can do here is at the top here, you have an option to select an input and output. So we got digital I/O, and we can tell the controller that when you want to start this process, it sends a signal, and you can select your signal here, out to initiate something to happen, right? It can be an output. It can also be some type of function or expression. So you can write some type of code here to work with other parts of the program. So if we keep it simple, we say, hey, I want digital output 5 to fire up once this process node is initiated in the program process. And then that would say, I want to start dispensing glue. So as you're rotating a part and you're running the robot around the face of that part, you can dispense that glue around that. Now, let's say if you have some type of other input that you want to see go high or low based on that process now being active, you can set that up here. So now you have this input from the start process. You can also say, let's say we're using some old welder that someone wanted to implement with the robot, but they want to do coordinated motion with it. They could say, I want to make sure that welder's output to us is high. That means that the power source is seeing a successful arc and it's maintaining that arc. So as long as this signal stays in the state that you've selected, you can continue running that process. If that signal went low or high based on your selections, then the robot would stop, just as it does with our more intricate setup with the Fronius power source or the Hypertherm or the IHT or whatever equipment that we would provide for you as our complete solution. So what you can do is you can take this software, buy the software from us, load it on the robot, do your setup, and then you yourself can actually set these signals up so that this is flexible in a way that makes you more effective and allows you to do the things that normally it would take a software engineer to implement.